Here we are in section 2.2 exercises part C with the solutions to numbers 1 through number 9. Okay, evaluate the following when f is 5, r is negative 7, t is 2/3, and a is negative 2. Oh, I'm glad they told us what they were. Here we have 6 times t minus f to the third power. So we're going to take t is 2/3 and stick it in right there. And f is 5. So we're going to take this 5 and stick it in right there. We now have 6 times 2/3 minus f to the third power, 5 to the third power, or cubed. So 6 times 2 is 12, divided by 3. 6 times 2/3 is 4, minus 5 times 5 times 5 is 125. 4 minus 125 is the negative of 125 minus 4 is negative 121. Let's double check our answer. Yes, negative 121. Good. Number 2, 10a minus 12 over 2f plus t. So we're going to take the a as negative 2 and stick that in right there by the 10. Then we'll take the f, which is the 5, and we'll stick it in right here. And then the t we'll stick in over off to the side right here. All right, let's see what we get with that. 10 times a negative 2 minus 12 over 2 times f, which is 5, okay, plus t, which is 2/3. 10 times a negative 2 is negative 20. Minus 12 is a negative 32. Divided by 2 times 5 is 10 plus 2/3. This is a fraction, negative 32 tenths plus 2/3. I think we'll punch it into a calculator. Here's a calculator we've used a lot. So we're going to take, and there's a positive 2/3, and the negative is over here with 32 tenths. And let's calculate, and it gives us negative 2 8/15, or negative 2.533. So negative 2 8/15. Let's check our answer. We get, yep, we have negative 38/15 or negative 2 8/15. Or if you wrote the decimal, that would be all right as well. Number 3. Ooh, we have a lot of them here. 2 times f, which is 5, times r, which is negative 7, minus 31 times a, which is a negative 2, plus 15 times a, which is a negative 2. So we've stuck all of these in where they go. 2 times 5 is 10, times a negative 7 is negative 70. Minus 31 times a negative 2, so this is minus a negative 62. Minus a negative 62 makes it a plus 62. Plus 15 times negative 2, that's plus a negative 30 or minus 30. So we're going to have negative 70 plus 62, that's a negative 8, minus 30 is a negative 38. Let's double check our answer. Negative 38, good. Number 4. Use the formula for interest. So there's a formula we need to get. Let's go into the textbook and back a few pages and let's see if we can find it. Here we have it, back a few pages. It's split between the bottom of one page and the top of the next, right after the percentage problems. It says interest. This formula is a summary of what we did in the last section. Yeah, remember we had the principal amount, the initial beginning, times 1 plus the interest rate, all to the number of years that it went. So here we go with, here we have an amount that's at the end of our savings, gaining interest, our principal, 1 plus r, so that's 1 plus the interest rate, all to the number of years that it is invested. Okay, so let's try that. We'll write it here for reference. A equals p, 1 plus r, all to the y power. Okay, so number 4, $15,000. So let's stick that in and we'll get $15,000 times 1 plus 0.062. And we've got to make sure we do that. That's a 0.062 because it was an interest rate. 1 plus 0.062 is 1.062, all to the, stick in 7 for where y is right there. Let's get our calculator to do this. 15,000 times 1.062 to the, and notice that the calculator does maintain order of operations. It will do exponents before it does the multiplication. It didn't hit equals between there, to the 7th power. And now we can hit equal, and we get $22,854.03. So 22,854.03. And that's how much is at the end of our investment. Let's check our answer. And yes, number 4, there it is. Number 5, notice we're not in dollars here, we're in British pounds. Same formula. So we get that the amount is going to equal the P, 2,300, times 1 plus 6% is 0.06. So 1 plus 0.06 is 1.06. All to the 8.7 power. How do you do 8.7 power? Not really sure, but the calculator will be able to do it. We get 2,300 times 1.06 to the, there's the exponent button, 8.7 power equals 3818.47 when we round up. 3818.47. 3818.47, and this will be in British pounds. Good, let's check our answer. Yes, there we are. Number 6. Here we're in, we have euros now. Same formula, the amount is the principal, 1,300 times 1 plus 0.089. We can just write as 1.089. That's our decimal, 0.089, moving it 2 places, all to the 7th power. Let's pull out our calculator and see what we get there. 1,300 times 1.089 all to the 7th power equals 2,361.23. 2,361.23, and this is in euros. There we have it. We should note that on these calculator problems, you could manually do the order of operations and say, I need to stick in 1.089 to the 7th power and hit equals, and times that by the beginning number, and it would come out to give you the exact same answer. Let's double check that. And yes, we have 2,361.23. Good. Number 7, use the formulas for money totals. And again, you may have to make up your own depending on whether we have pennies and nickels or pennies and quarters. Q stands for the number of quarters, D stands for the number of dimes, N stands for nickels, and P for pennies. So let's do this one. In this case we have V equals, we have quarters, dimes, and nickels. So 0.25Q plus 0.10 dimes plus 0.05 nickels. Okay, so this is our formula because we have quarters, dimes, and nickels. This, however, is an unusual problem because it says the quarters, we don't even know what they are, but it says that we have this many of them. T plus 5. I don't even know what that number is, but it tells us that's the number of quarters. So we stick it in just like normal numbers. We don't need to be scared of that. 0.1 times D, that's just M. Oh, hey, at least we get 13 over here. So this is telling us we have V equals 0.25 times t plus 5 plus 0.10 for 10 cents for dimes, 0.10 m, and then plus 0.05 times 13. Oh, hey, that's nice. We have a real number over here. 0.05 times 13, that's 0.65. That's a nice one. 0.1 m, just 0.1 m, can't do anything about that guy. This one, we've learned some ways of simplifying. We can distribute this guy in like that. So this is 0.25t plus 0.25 times 5 is 1.25. So we just use the distributive property there. Now we can combine things that are alike. So we get that V is going to be 0.25t, 1.25 and 0.65. Those guys can add together. They're like terms. 1.25 plus 0.65 is 1.9. And we have the plus 0.1 m. Now we might have mixed these up in a different order, but let's check our answer. That was kind of a tricky one. 0.25t plus 0.1 m plus 1.9 is correct. So when you're given a formula, they may have you stick in variables for other variables, and you can still simplify it as much as you can. Let's do number 8. Here we have that the formula where we got dimes and pennies. That's nice. So it's going to be 0.1 times the number of dimes plus 0.01 times the number of pennies. So this one looks like it's kind of nice. We don't have the crazy stuff that was going on in number 8. 0.1 times 9 plus 0.01 times 15. So we get 0.90 plus 0.15, and we get 1.05. So the total value in this one is $1.05. Let's check our answer. And it is $1.05. Good. Number 9. Here we have that the value is going to be, we have pennies, quarters, and nickels. 0.01 for the pennies, plus 0.25 for the quarters, plus 0.05 for the nickels. And, this one we have these unique things to stick in again. So h plus 9 is going to go in there. 7, normal number, is going to go in for the quarters. And x minus 20 is going to go in for the nickels. All right, let's give that a try. Let's see if we can do it. So the volume is going to be 0.01 for the pennies, and that is h plus 9, plus 0.25 times the q, which is 7, plus 0.05 times the nickels, which is x minus 20. All righty. That's correct. We've stuck them in. Now we just need to simplify what we've done. Here's a parentheses. We're kind of stuck with these letters in here, so we're going to distribute so the parentheses are no longer there. This one in the middle is just, it's not distributing, that's just multiplication. So it now equals 0.01h plus 0.09 plus 0.25 times 7 is 1.75 plus 0.05x and minus 0.05 times 20 is 1.00, so minus 1. Okay, let's see if we can find all the common things here. We have 0.01h. There's no other h's. Here is the x's right here, so plus 0.05x. And then the rest of them are all numbers. So we can take 0.09 plus 1.75 minus 1. Let me see if we did this. 0.09 plus 1.75 would be 1.84. Minus 1 is 0.84. So this is, in this problem, this is what V turns out to be. Let's check our answer. V is 0.01h plus 0.05x plus 0.84, and that is correct. Good.